Mindsetters, welcome to it, Grade 12s. This is your show, your favorite show, Learn Extra Live with me, Abram. And of course, I'm joined by Temlin. Happy Women's Month, and I hope you enjoyed your Women's Day.
I really did. I did indeed. Thank you.
All right. Are you well, though?
I'm very well. How are you?
I'm very good. I'm all chilled up. I was ready, it was the long weekend, but to me it was very short.
Yeah, I know, always. But now some of us on holiday, some of us are still getting ready for prelims, so it's a bit all over the place, hey?
Well, otherwise, work has to be done either way.
Absolutely.
And what are we going over today?
Okay, today we're kind of doing an extension of what Dean has actually just been covering with 2D triangles, but I'm going to add a little bit more to it by adding 3D triangles to it, so making it just a little bit more difficult for those grade 12s.
Nice one. I like that. Well, Mindsetters, there are three things that you need to know. Is that one, you can join us on Facebook, chat to us, facebook.com/learnextra. Like our page and be one of our Mindsetters, because currently we're having about 49,995 Mindsetters. So 5 more to go, Mindsetters, to reach 50,000. So get your friends who like the page if you already like the page, because it's convenient learning. You learn and chat at the same time. You can help other Mindsetters, and also you can be helped by the Mindsetters on the page. Secondly, you can follow us on Twitter at LearnExtra. And lastly, you can download your notes for free on learnextra.co.za/live. I'll be telling you some exciting and great news as the show goes on. But for now, Temlin, take it over.
Thank you so much, and welcome grade 12. I certainly hope you guys were all watching earlier where we had a grade 11 show on all your 2D trig. It was some good revision for you, so I hope you were all paying attention. Let's have a quick look at what we're going to be doing today. All right, so today we're going to be having a look further at the area, the sine, and your cos rule. When we apply them, how do we know which rule to apply in which situation? We're going to have a close look at all of that. And then we're going to be looking at the area, the sine, and the cos rule, not only in your 2-dimensional triangles, but we're going to add a 3-dimensional triangle into the whole mix, and we're going to see how we can apply those rules in solving missing angles and missing sides of 3-dimensional triangles. Right, so I hope you guys are ready. Okay, for those of you who were not watching earlier, let's very quickly go over our rules. Okay, so when do we typically use the area, the sine, and the cos rule? Generally, when you have got a triangle that does not have a 90-degree angle, okay? Remember, if you've had a triangle that had a 90-degree angle, then generally we would go back to using our normal ratios for sine, for cos, and for tan, okay? But if that right angle is not there, then obviously what we need is a rule to help us find those missing angles and sides, and that's what these rules are here to help us do. Okay, so the area rule, let's have a look, guys. The area rule states that to find the area of triangle ABC, what we have to find is, okay, taking, for instance, I have an angle A as a known angle, I have side C as a known side, and side B as a known side, okay? In order for your area rule to work, please remember that the known information that is important, what you need to have, is that you need to have a side, an included angle, and then a side, okay? So in order for your area rule to work, please remember that's what you do need to have is a side, angle, side. The angle must be included, okay? All right, so in that case, we would say half of the 2 sides that we have, so half of BC multiplied by sine. In your area rule, just remember it's always the ratio of sine of the angle that we know. Okay, so the other 2 is just changing the perspective. So this should actually be a B. All right, let's just quickly look over here. So therefore, if I knew angle B as a known angle, then I would need to know side A, and I would need to know side C. So to get our side, angle, side. And in that case, I would have half of the 2 sides AC multiplied by sine of that included angle, which is angle B. And the same would happen for your third angle C. So that's the rule that we need to apply with our area rule. Okay. The sine rule. Okay, Dina did go through this in quite a lot of detail. Okay, just to quickly run through it with you guys. When do we use the sine rule? Okay, this is typically when we are sitting with the following. If you've got an angle, if you've got a known angle and you've got a known side, and that angle and side are opposite each other, they form a pair, okay? They have an opposite pair of a known side and a known angle. If you have got that pair, that is then when you know you can use your sine rule, okay? So if I know A and I know little a, and let's say I do know what B is, but what I'm trying to find is the size of side B, that would then be an instance where we would actually use the sine rule, okay? So the pair is what you are looking for in terms of knowing whether to use your sine rule or not, okay? Another thing very quickly is that normally what we do is we keep the ratio of what we're looking for, so we keep the unknown over the known. So generally speaking, guys, if you're looking for a side and you know an angle, then we put the side on top. So we would have little a over sine of angle A, okay? However, if it's the angle that you are looking for and it's a side that you know, then we're going to invert that and we're going to put the unknown angle, so in which case I would say sine A over the known side. And if that was the case, then I would have it look like so. Okay, so just try and remember, it's quite a handy rule to stick to always put the ratio of your unknown value over your known. Okay. Right, and then we've got our Cos rule. Okay, so let's say we've now got this triangle. You've tried to find the pair of a known angle and its opposite side, and you don't have one. All right, so there is no pair here of an angle and an opposite side. That is when you are going to look at using your Cos rule. Okay, the Cos rule needs to do this. We need to have an angle. We need to have two sides, and again, it needs to be an included angle between the two sides. Okay. If I look here, I know side A, but I know angle A, sorry, but I don't know side A, so there is no pair. I know the side B, but I don't know the angle, so therefore there's no pair. I've got a side, but I don't have the angle, so there's no pair. Okay, so that's when I want you to then think, okay, obviously here, I need to apply my Cos rule. The way your Cos rule works, remember it's derived from Pythagoras, okay? The side that we are looking for, we'll say little a squared equals b squared plus c squared minus 2bc, so we keep those same sides over there, bc, multiplied by cos of the angle between those two sides. Okay. Now, when you're working with the Cos rule, just be aware, guys, that you are either sitting with a situation where you've got two sides and the included angle, or you could be sitting with three sides. Okay, if you've got all three sides and no angles, you can use that Cos rule to help you find your missing angle. Okay, it just means that different information will get substituted into your formula. I'll do examples with them with you so you guys can just see how it gets applied, but that's what you need to look for. Either two sides with the included angle or three known sides. Okay, before we go on, I just want to speak to you very quickly about the ambiguous case in your sine rule. Okay, the ambiguous case is applicable to your sine rule. And this is important because sometimes it catches you out. So I'm going to quickly give this to you as something to watch out. Okay, I'm going to give you a triangle. All right. And I'm going to call this triangle ABC. All right, and I'm going to call this length over here 10. I'm going to give that 17 units, and let's call that 35 units. Okay. The question here wants to know, oopsie, let's just put that back. The question wants to know what is the size of angle B. Okay. So not using the sine rule, and this is just a bit of revision from grade 11, how would I go about doing it? Well, we've got a pair of an angle and a side, okay? I know this side over here, but what we are looking for is that angle. So we're going to apply your sine rule, and we're going to say the length of, we're going to take sine of 35 degrees as my known angle over the side opposite that, which is 10, and we're going to make that equal to sine B, angle B, over the side opposite that, which is 17. Okay, to now work out what sine B actually is, I'm going to multiply my 17. I'm going to cross multiply it, so therefore sine 35 over 10 equals sine B. All right, and let's grab our calculator. Let's work out what that is. Okay, that's clear. Right, we've got a fraction. I've got 17 multiplied by sine of 35, close your bracket, over 10 equals. I then need to work out what b actually is, so don't forget to move your sign over your equal sign. We shift sign on our calculator. So shift sign of the answer that was in your calculator, and I get 77 point, let's round it off to 77.2. Okay, so 77.2 degrees would be the size of angle B, all right? That's over there. And I'm sure you guys agree that if you look at it, it is an acute angle. It should be 77, so we're happy with that. Okay. However, here's the ambiguous side of this whole story. I'm going to erase these lines over here quickly, just to not confuse anyone. And let's put back some numbers. We said that that was 10, and we said that that was 17. We said that that was 35. Okay, I'm going to add in another line. I'm going to put a line into my triangle like that. Okay, it's not exact, but I want to make sure that I want to make them look the same. All right, they're equal to each other. So therefore, in fact, this line over here is also 10. All right. So let's look over here. That creates a new angle over there, which let's call it angle D. Now, can you see that to calculate the size of angle B, I had a length of 17, I had a length of 10, and I had an angle of 35, all right? However, if I now put my attention into this triangle, I've got a length of 10, I've got a length of 17, and I've still got an angle of 35. But the big difference here is that this angle is acute, and that angle is obtuse, okay? So what am I going to do? Because technically I would have to use exactly the same calculation as I have over there to work out the size of angle D, but we can see that D is an obtuse angle. So guys, what you need to watch out for is to look at your angle, all right? If you've applied your sine rule and you can actually see that the angle is bigger than 90 degrees, you will actually have to work out the supplementary angle of that 77.2 as well. So the other option here is to say 180 degrees minus 77.2 degrees as the other, no, in fact, it's not B, it's D here. Let's just take out that. And that would actually be then the size of angle D. All right, so just to watch out for that, please, that's called your ambiguous case. What you need to look at is your diagram, okay? Look at your diagram, see if it's an acute angle, which is very clear. You can see it's less than 90 degrees. If your angle is correct, great. If it's not, you need to then work out its supplementary angle. Okay, all right. So let's get on to some more interesting examples. All right, let's have a look at what we've got over here. We've got a piece of land that has been formed from a quadrilateral ABCD, and we have been told the following. The length from A to B is 20 meters. The length from B to C is 12 meters. From C to D is 7. And A to D is 28. Right, and what I know is that my angle is 110 degrees. So the first thing that they're wanting me to find over here is the length of AC. That's this length over here. And they want us to work out what is the length of that AC over there. Right, so what do we have to do? I want you to very carefully look at your diagram and ask yourself, do I have a pair of an angle, a known angle, and its opposite side that I know the length of? If you've got that known pair, you know that you're going to be able to use your sine rule. Okay, so have a look at it, guys. I know that I've got an angle of 110, but at this point, I don't know what the length of AC is. So there's no pair over there. I know that this length is 12, but I don't know what angle A is. So therefore, once again, there is no pair. And I know what BA is, but I don't know what its opposite angle of C is. So there's no pair. Right, so therefore, the sine rule is not going to be applicable here. We are going to need to use your Cos rule, all right? And the Cos rule is going to then be applied as follows. To find the length of line AC, I'm going to say AC squared is equal to, remember you had to take the two sides and the included angle. So I'm going to take the length of BC squared plus the length of BA squared minus 2 multiplied by BC times by BA times by cos of the included angle, which in this case is angle B. Okay, so now we're going to substitute it in. So the length of AC squared is equal to, BC was 12 squared, BA is 20 squared, minus 2, whoops. Let's just go up here, 12 times by 20 times by cos of 110 degrees. And the good news here is that you can actually type this into your calculator as you see it. So therefore, let's grab our calculators out and let's type in what we've got over here. Right, we had a 12 squared plus 20 squared minus 2 multiplied by 12 times by 20 multiplied by cos of 110 degrees, and that is equal to 708 let's round it off to 0.2. Remember, it's not AC yet, that represents AC squared. So remember, you must square root your answer. So I'm going to square root the answer that was in your calculator, and we are getting 26.6 as the answer for AC. Okay, so 26.6 is my answer there. And it's meters. Okay, right, so we identified that the fact that there were no pairs there, no pair of a known angle and a side, told me, it guided you that that was where you had to go and use your Cos rule. Okay, next one. Now that we know that that's 26.6, so let's just fill it in here to help us out. All right. Now they want to know the length, the size of our BAC. So my size from B to A to C, we're looking for our angle over here. All right, to the nearest degree. All right, once again, guys, go back and see. Have I now, by actually having found the distance from A to C, do I now maybe have a pair of an angle and a side? Okay, and in fact, yes, you do. I've got an angle, which I know is 110, and I now know its opposite side, which is 26.6. So now we're going to be able to use the sine rule. Okay, I've got that side over there, and we are going to apply it. I think we probably have time for an ad break, am I right?
Yes, you're right, Timmy.
Okay, so what I'm going to suggest, guys, is quickly get the answer to that one, and I'm sure we'll be back in a few minutes.
You know what? The mindset has just made my day. I'll tell you about the good news that I have over Facebook right after the break. Don't go anywhere. Welcome back, matriculants. Now I've got some exciting news that I need to tell you about. As Mindset Learn Extra, we've reached 50,000 likes on our Facebook page. So that is just exciting for me.
That's awesome.
And the page is just buzzing. The Mindsetters are also excited. So this calls for a celebration after the show. We're going to celebrate on Facebook. But otherwise, also on a good note, as we try to help you guys, you can take our Curio assessment on curio.co.za or log in via your Mixit and look for Curio. The code is M11. Take that assessment so that we can help you to see whether you understand or where you're struggling. So Temlin, with that excitement, let's continue.
Yeah, absolutely. Well done, Mindsetters. That is just awesome news, and I just hope that what you are learning is just is amazing as well. So well done on all of that. Okay, very quickly, I'm sure you guys all did that during your during the ad break. And the angle A was 25.1 degrees. Okay, so just have a quick look at it. I used the sine rule, and yours should look fairly similar to mine at this point. Okay, right. Then on the same question, they're not done with us yet with this question. They now want us to calculate the size of angle D. Okay, so there's angle D, correct to the nearest degree. Okay, so having said that, go back to looking for your pair. Okay, so we obviously, if we're looking for angle D, I think it's fair to say we now have moved into this triangle over here. And what have I got? I've got a side, but I don't have the angle opposite the side of D, so there's no pair. I've got C, which is an angle. I don't have the angle, but I do have its side. I've got A, which I don't know the angle, but I do have its opposite side. So I'm sitting with no pairs. So once again, the sine rule, unfortunately, we can't use. So what are we going to then fall back on? Your Cos rule, okay? And the Cos rule, as I mentioned earlier, you can find the size of a missing angle with 3 sides of the triangle you just need to apply your Cos Rule. Okay, so this is how you're going to go about doing it. Okay, take the Cos Rule as you know it. All right, which would mean this. If I've got that as angle D, I'm going to call that side little d. I'm going to call this side over here little a, and that little c. All right? So therefore, the Cos Rule would typically look like this. To find, if I knew angle D, I would actually start with the side opposite that. So I would start with little d, and I would say little d squared is equal to the two other sides, which is a squared plus c squared minus 2ac cos d. Okay? But the part of the equation that we don't know is in fact that. Okay? So what I would need to do is I just need to rearrange the equation so that I can actually get cos d on its own and everything else off on the other side, because that's what I need to solve for. So let's see if we can do that. In order to get cos d on its own, all right, I need to move my a squared over the equal sign, and I need to move my c squared over. So the first thing we're going to say is that d squared minus a squared minus c squared would be equal to a negative 2ac cos d. Okay? All right, so cos d is not completely on its own just yet. Now what we're still sitting with is negative 2ac. And the negative 2ac, remember, is joined to your cos d by multiplication. All right? So please don't make the mistake of thinking you need to add ac onto the other side, because it's not. This is all one term, all right? So you can't separate it with addition. You need to get rid of it by doing the opposite of times, which is divide. Okay? So therefore, we're going to have this. I'm going to say d squared minus a squared minus c squared all over negative 2ac is going to leave you then with cos d on its own. Okay, so all I've done, grade 12s, is I've just rearranged the normal Cos Rule formula. Okay, and now that we've done that, let's substitute in what we've got. Let's quickly just write it over here so we don't have to keep moving it. A was 7. C is 28, and D was 26.6. Okay, so let's sub that in. Okay, so we've got D, which is 26.6 squared, minus A, which is 7 squared, minus C, which is 28 squared, all over your length of negative 2A, which was 7, and C, which is 28. And we're still trying to find cos D. Okay. Right, guys, calculators out. And now we need to substitute in. Okay, so we've got our fraction. We've got our fraction of, 26.6 squared minus 7 squared minus 28 squared. And that is over negative 2, 7 times by 28. And that has left us with 8 over 25. But okay, so let's just quickly write that down. 8 over 25 is what we have as a ratio. 8 over 25. That's equal to cos D. Okay, I'm not interested in cos D. I just want to know what D is. Remember, that's what we're trying to find, is the size of the angle. So therefore, we need to move cos away from it. And the way we're going to do that is say shift cos of the answer, and we've got 71.3. Okay. And there we go. That's the solution that we're looking for. 71.3 degrees, which is the size of angle D. Let's just make sure that it is an acute angle. Remember, we don't want to make any silly mistakes with that. I'm happy with that. 71.3 is going to be fine in terms of angle D. Okay, so there we go. That's one of your, definitely something to watch out for when applying your area and your Cos Rule, is that, yeah, if you're trying to find the angle with 3 known sides, that's how you're going to do it using your Cos Rule. Okay.
I have 2 questions for you before you move from that.
Yes.
Walani says, let's say I didn't find the length of the line. Is there a way to find the angle BAC without the line calculated?
Okay, let me go back to the question very quickly and let's have a look. Okay, so the angle BAC, and presuming that you didn't know AC. Is that the
Let's say I
question?
didn't find the length of the line. Is there a way to find an angle BAC without the line calculated?
No, you would have to. So let's just say that they hadn't actually, because often a question will be broken up into pieces where it sort of guides you along in terms of what you need to know. However, it won't always do that. So let's presume that you were asked for angle A straight off, and that was what they were asking you to find. You would need to know that, yeah, you don't have enough information there. You would need to actually use your your Cos Rule, to find the length from A to C and then apply your sine rule. So in that case, you actually did need that length over there.
All right,
Okay.
and then lastly, quickly, Kolani Nxumalo says, Khumalo, is there a trick of knowing which rule to use?
You know what? My shortened version of everything, which I've said a couple of times already, is this. Look for a pair, okay? If you've got a pair where you know an angle and you know the opposite side, okay, that is telling you can use your sine rule, okay? If you don't have a pair, all right, then that's generally your Cos rule. So just watch me as I'm going throughout the rest of the show and just see how many times I actually say to you, do you have a pair? Because if you do, sine rule. No pair, Cos rule. That's kind of the short trick to look for.
All right,
Okay.
next one.
Okay, guys, and I think the last question, what they're asking us for here is the area. Okay, they're wanting the area of ABCD. So I'm actually going to go back to the previous diagram, which has all the numbers on it. We had 71.3. Okay, so to calculate the area of this whole quadrilateral, which is not a regular quadrilateral, so it's a bit of a strange shape, we have to then obviously divide it into two triangles, okay? So to work out the area of the whole quadrilateral ABCD, I'm going to first of all work out the area of that triangle over there. I'm then going to work out the area of that triangle over there, and then obviously add them together. Okay, what do we need as known information in order to use your area rule? Please remember, you need a side, you need the included angle, and then you need the next side, okay? So side, angle, side. In this triangle, in the pink triangle, do I have that information? I've got an angle. I know that that's 110. I know that this length over here is 12, and I know that that length over there is 20. So I hope you guys agree with me that I do have the information that I need to apply my sine rule. So let's start with the area of triangle, and we're doing triangle BABC. Okay. All right, I'm just writing it underneath because I don't have space, but obviously you would normally write it next to you. I'm going to say a half of, now the two sides, remember that's going to be little a over there because that's opposite angle A, and this side over here is little c because it's opposite angle C. So we would normally start by saying half of AC multiplied by sine of the angle in the middle, which is angle B. Okay? So half of A, which is 12, multiplied by C, which is 20, times by sine of 110, and we're going to type it in our calculator. Okay, so let's do it. We've got a half, which I'm going to just put in as 0.5. I've got 12, I've got 20 multiplied by sine of 110, and we've got 112.2 as a point. Okay, let's round off to 112.8 as the area over there. And obviously we're talking about meters, so it would be meters squared. And guys, the same thing would happen in the bottom triangle. So we would apply the area rule as well, and we would add it together. Okay, so I'm going to actually let you guys do that one for yourselves. It's easy enough to do. And we're going to move on to the next question.
And
Okay.
then,
Yes.
just as you're about to move on, because I see you've also rounded off there, Cat Twiki Chocolate says, how do I know when to round off? Because it seems like I always round off before the final answer.
Yeah, rounding off, remember rounding off immediately makes your answer less accurate, okay? So your best bet is to do this. On your calculator, let me bring up my calculator. Let's say I am trying to work out, let me just think of something very quickly over here. Let's say I've got, sorry guys, I'm just going to write it over here on the side. Let's say I've got 12 sine 20 over 10, and I'm trying to work out, I hope this works, this is just out of my head now, sine of A, okay? If it doesn't work out exactly, then you'll know what I'm doing just by the process, okay? All right, so what we would do over here is we're trying to find the size of angle A. So what you would do is you type all of that into your calculator, okay? And it's going to give you a decimal. So we're going to have 12 sine 20, and it's over 10, and it gives you, let's hold thumbs. Okay, that'll work. So it gives us quite a big, long decimal, okay? So the ideal situation is don't clear your calculator there, all right? Don't round it off at this point. Leave the answer over there. And what you need to now do is this. You want to solve for A. So on our calculator, we're going to press Shift. We're going to press Shift sign of the answer. Can you see the button that I pressed at the bottom over there? The answer, no, I don't want two of them, and equals. And then that'll give you your most accurate answer, which at the final step you would then round off. So at the final step I'd say, okay, well, if I'm rounding it off to 1 decimal place, 3 would leave as 2, so I would have 24.2. So that would be my best answer, is to keep your decimals as much as you can in your calculator, round off in your final step. Okay.
Thank you.
All right. Okay. Let's see what else we've got here. Okay, let's have a look at this question over here. We have got a tower. Okay, we've got a tower, which is 25 meters in height, and they've given that the values of TB. And 2 cars, K and L, are on the road. The angle of depression, okay, remember guys, just regarding angles of elevation and depression, they're always from a horizontal viewpoint. So your angle of depression has got to come from that horizontal line down to the point on your diagram. And an angle of elevation will go from a horizontal viewpoint looking up, okay. So the angle of depression from T to car L is 10 degrees, and the angle of elevation is 17 degrees. So let's see what they want us to look at over here. Now, bearing in mind, because this line over here and this line over here are horizontal, obviously they're going to be parallel. Okay, so the very first question is actually asking me to find the size of angle L. Now, knowing that these lines are parallel, my angle of depression over here is going to be an alternate angle to angle L over there, which is also going to be 10 degrees. So my angle L is 10 degrees, and the reason we know that is because we have alternate angles between the parallel lines. Okay. All right, so just a point on angles of elevation and depression, that they always are between horizontal lines, which are parallel. Okay. Now that we know that this is 10 degrees over here. Now they're asking us to calculate the length of KT. So let's see over there. That's the length of KT. So from what I can see over here, guys, I've really got 2 triangles that I could actually look at over here. I've got my triangle. In fact, no, I've got 3 triangles I could look at over here. I've got the big triangle, which is triangle TBL. Okay. I've got this right angle triangle TBK. And then I've got triangle TKL, all right? So we've got to decide which triangle is it that we need to actually work in over here to find the length of KT. Okay, so first things first, my big triangle, KT, is not a side of that big triangle. So it's not going to work over there. It's either part of the right angle triangle or it's part of your other triangle, this obtuse angle triangle. And if we have a look here, the right angle triangle is the one that we have the most information in. I know the length of 25. I know that that's 17. And the fact that I've got a 90-degree angle would imply, guys, that we can just use normal trig ratios. Okay. So I'm going to once again let you go and try that during our break, okay? And just go and have a look at it, see if you can find me the length of KT, and we'll do it when we come back.
Thank you so much, Chameleon. Do not move, Mindsetters. We'll see you after the break. Welcome back, matriculants. Now we have some awesome and exciting news just for you. If you know anyone who could be interested in joining our team, we're looking to hire someone who's interested to be part of our grade 10 to grade 12 CAPS content development, review, and video presentation. If you know that person, or if you are that person, go to mindset.co.za/learn/jobs. Now the closing date is on the 26th of August. So go on that website and find out more about the job opportunity. infinity. Thank you, Tamlin.
Right, guys. Okay, so I know you all went there, you worked it out, and you've got 26.1 as the distance from K to T. Okay, so it's the process you need to go through. You need to look at the question. You need to assess, what do you have? What are you looking for? Which triangle has got more information in it? Because that's going to guide you as to which triangle you need to actually be working in. Okay. So we now know that this length is 26.1, and the next question is asking us to now determine the length between the two cars, which is K and L. Okay, so that's what they're wanting us to do. So let's look. So obviously KL, guys, I'm sure you agree, is going to be a side of the triangle KLT. So it's this thin, obtuse triangle on the side over there. Now, it's a bit thin on information as well. It doesn't really have too much for us over here. And I know that this is 10. I now know that this is 26.1, but that's it. That's all I know, okay? So here is where you also have to start finding stuff for yourself, and this is a really important part of trig triangles. You need to find missing angles. For instance, if K1 is adjacent to angle K2, then together they add up to 180 degrees, okay? So 180 degrees would be because they're angles on a straight line, and if I take away your 17, we're getting 163. So this angle over here is 163 degrees, which is going to allow me to find one more angle, because if this is 163 and that's 10, the angles inside a triangle add up to 180, which is going to allow you to find this angle up here, angle T2. So take your full 180 degrees, take away the 163 that you've just found, and take away angle 10 that we've just found, and it leaves us with 7. So we need to just fill this all in. So we need to state that angle T2 is equal to 7 degrees. Why? Because it's the interior angles of a triangle. Okay. So we now know that that's 7 degrees. Now that's really helpful to us, because now what do I need to look for? Always start by looking for a pair. Do I have a pair where I know the angle and I know the opposite side? And if we look carefully, I know this angle over here is 10, and I know that this side over here is 26.1. That forms a pair, okay? And that being said, I now know, I know that that's 7, and I want to find this length over here, which is KL. So can you guys see that I'm using the pair, which means I'm going to be using the sine rule to find my distance from K to L. So I'm therefore going to say my length from K to L over sine of the angle opposite that, which was 7 degrees, is equal to the length which I've just found earlier, which was 26.1 over sine of the angle opposite that, which is 10 degrees. So therefore, your length from K to L is going to be equal to 26.1 multiplied by sine of 7 degrees over sine of 10. Okay, so let's clear our calculators and let's put that in. I've got 26.1 multiplied by sine of 7 degrees, and it's over sine of 10 degrees, and we're getting 18.3 as our answer. So my distance from K to L is 18.3 meters as the distance between the two cars. Okay. Now we're going to move on to working with triangles. We are still applying your area and your sine and your cos rule, but now we're going to take the numbers away. Okay, now we're not going to work with any values in terms of actual numerical values. We're going to give them symbols. So let's have a look at this example over here, and let's see what we can do with this. Okay, I just need to find it. This one here. There we go. Right, now let's see what we know about this. Okay. Right, we have got a triangle. I've got triangle ABD, and then I've got a smaller triangle ABC. All right? What have I been told? I know that my length from B to C, which is equal to my length of CD, is equal to K. They're my two little Ks over there. My angle of ABC is equal to X, and my angle of CAB is equal to Y. They want us to prove that the area of triangle ADC is equal to, and they've given us this quite large this large formula over here that we need to get to. Okay, so this becomes a little bit more tricky in the fact that obviously there's no numbers involved. So tip number 1, okay, if you've got a question like this, grade 12s, start off by finding as many missing angles as you possibly can, okay? The reason why I say that is because you want to see if you can find a pair of an angle and a side. And if not, obviously you know it's your Cos Rule. So find missing angles. That's tip number 1. Find missing angles. Okay. So what do I mean by that? Let's have a look here. If this angle over here is y and this angle over here is x, then I could say that this angle over here of c, let's make it a different color, is 180 minus x plus y because of the interior angles of a triangle. Okay. I could also say that this angle over here is going to be just x plus y. And there's 2 reasons for that. Either you could have said it's because of adjacent angles on a straight line, or you could have seen this angle C as the exterior angle of this triangle. And remember, the exterior angle equals the sum of your opposite interior angles. So that xy is equal to angle A and B together. Okay, so we found a few missing angles over here. What else can we do? At this point, I think we have found as much as we can find. Okay, so they're asking us for the area of triangle ADC. So we're looking for this triangle over here. Let's make it a totally different color. We're looking for the area of this triangle over here. Right, next question we need to ask ourselves, what information do we need in order to apply your area rule? Okay, we need a side, we need the included angle, and we need another side. So let's see if we have that. I need a side, which in terms of variables, I know what that is. They've told me it's the value of k, so I've got a side. I need the angle in between, which I've just worked out is x plus y, so I've got an angle, but I have a problem. I don't have a side over there, okay? So that means that I have to then go back a step, and I have to look at the other triangle and see if there's maybe a way that I could apply my rules to help me find the distance from A to C. Okay, so let's look carefully. What information do I have in this triangle ABC? First, look for your sine rule. It's the much easier one to apply, and generally, you'll find you'll often have a pair there, so look for it first. I've got an angle of A, which is y, and I've got a side, which is k. So do you guys see the pair? Okay, I've got a pair over here. I know that this angle over here is x, so I'm going to use my sine rule to help me find the distance from A to C to start off with. So let's do this. My length from A to C over sine of the angle x is equal to the side which I know, which is a k, over sine of the angle opposite that k, which is just y. All right? That means that my length from A to C I'm going to be able to write as k multiplied by sine x over sine y. And that's it. That's what I would leave it as.
Can I just ask you, Timlin,
yes,
why did you use the cos, not the sine, on your KT?
Okay, sorry, let me go back and just see what you're saying there. K from K. Are we looking at the previous example?
Yes, yes.
Oh, I'll tell you what, let me go back over that. Sorry, let me finish this question so I don't break the train of thought, and then I'll go back, okay?
Okay.
All right. Okay, so where we were is that I found the length from A to C. That solves your problem, guys, because now you have the missing side that you were looking for. So the question was asking us for the area of triangle ADC. So let's now do that. So the area of triangle ADC is going to be half of my distance, I'm going to call it little d, multiplied by, where am I? Little a, multiplied by sine of the angle in between the two, which is C. Okay, so let's plug in all of that information. So I've got half of little d. Now remember, that's this side over here, little d. And that was this whole story of k sine x over sine y. And that's little d. Then this side over here is k, so we're subbing that in, and it's sine of the angle in between the two, which was x plus y. Okay, and when I multiply that all out, let's see what I've got. I've got a k times a k. Oh, I didn't want to jump there. So we're going to have k squared multiplied by sine x multiplied by the sine of x plus y. And that's over, I've got a 2 in the denominator, and I also have a sine y in the denominator. And if we have a look, guys, that is exactly what they were wanting us to prove. Okay, so there we go. It looked kind of confusing with all the k's and the x's and the y's, but I'm sure you'll see that all I did was applied the sine rule as normal, and I applied the area rule as normal. It was just with letters and not numbers. So the application of the rules is exactly the same, and that's what you mustn't forget. Okay. All right, let me go back to the question and see which one it was that you were questioning. I need to find it. Okay, I think it was this one. All right, sorry, if you don't mind asking the question again.
All right, why did you use the cos, not the sine, to find your kt?
For k to t. Oh, okay,
Yes.
all right. That was going right back to the very beginning, okay? In the very beginning, I used the information that I had. Okay, so the first thing was I was working in a 90-degree triangle. Okay, so because I was working in a 90-degree triangle, I could use the ratios of sine, cos, or tan, whichever one I had the information of. I was working from angle 17 over there. Now this side is your opposite side, all right? And kt, was your hypotenuse. So in fact, I think you're absolutely right. I may have made a mistake there.
All right.
It actually is the sine rule, sorry, because it would have been the opposite over the hypotenuse, which is sine. I'm not going to redo it because the sum would work out exactly. You would do the working out the same way. Sorry, well spotted. That was actually the sine rule. Okay, not the sine rule, sorry, the sine ratio. All right. Okay. Do we have time to throw one more question at these grade 12s? I think we do. Okay, right, guys. Let's do one more question here, and let's see how we manage with this. Again, I'm not giving you any numbers here, so you just need to be able to apply your rule without the numbers, okay? So read carefully what's been given to you. Let's see what we've got. P, Q, and R are 3 points in the same horizontal plane, okay? When we talk about this now, you've got your vertical side and you've got your horizontal side of the triangle, and that's what this diagram is actually showing you from a face-on point of view. You've got your vertical side, and then that bottom triangle is actually the flat side of the triangle that's sitting like that. So that's the three-dimensional aspect of this now, okay? So we've got in the same horizontal plane, PT is a vertical pole, okay, that's implying there's a 90-degree angle here. The angle of elevation from R to T is beta. Q is equidistant, which means they're equal to each other, and we've got an angle of theta. They are ultimately wanting me to prove that PT, so my length of PT is equal to all of this. So let's go and see what we can do here. They have told me that these two triangles are equal in length. Now normally, guys, if you're trying to find the length of this side over there, it's normally the other triangle that you are going to start in, okay? So generally, if you need to finish off in this triangle, I want you to start in the other triangle, okay? You've got to find your way up through the triangle to get to the side that you're looking for. So this side over here, the length of PR, I'm sure you guys agree with me, is the connecting side between the bottom triangle and the top triangle. So ideally, we need to know what the length from P to R is, okay? And that's what I'm going to do over here. Now, PQ and PR are equal to each other. So those are two equal lengths, and I've got the angle in between the two. So basically, I've got two sides and an included angle. That's going to tell me to use your Cos rule. There are no pairs here, all right? So using my Cos rule, I'm going to say this. To find my distance from P to R squared, that's going to be PQ squared plus QR squared. But this is what I'm going to do here, so please watch this carefully. PQ, I was told, is the same as QR, okay? So I'm not going to refer to it as QR over here. I'm going to refer to it again as PQ. Why? Because look at what they're trying to ask you to prove over there. There's a PQ in there, okay? So I'm kind of leaving the QR off and just referring to it as PQ, okay? Minus 2 multiplied by your two sides again, so PQ times PQ, times by cos of the angle in between, which is cos of theta. Let's tidy this up. That would give me 2PQ squared minus another 2PQ squared multiplied by cos theta. why can I not just cancel those two out? Because that 2pq has got a cos theta attached to it. So those two can't just cancel each other out, if that's what you're thinking. So what can I do over here? I'm going to take out a pq squared as a common factor, all right? And that's going to leave me with, a 2pq squared as a common factor, which will leave me with a 1 minus cos theta that's inside my bracket. Now, if we start looking at what we're trying to prove, it's starting to take shape. It's starting to look a little bit like we want it to. Okay? Remember on this side, however, that you've got a PR squared. Okay, so to get rid of your PR squared, or to get rid of the squared at least, we are going to square root it. Now, the square root of PQ squared is just PQ, but the rest of it is going to have to be underneath the square root sign, so 1 minus cos theta. Okay, so that's the length of this side over here. Excuse me. Now we have to find your length from P to T, knowing that I have a beta over there. Because I've got a right angle triangle, you can just use your normal ratios of sine, cos, or tan. And in this case, this over here would be your opposite side, and this over here would be the adjacent side. And opposite over adjacent is going to give us the ratio of tan. So I'm going to do it here so I've got space. So we're going to say tan from angle beta is equal to the opposite side, which is TP, over the adjacent side, which I've just worked out, is PQ root 1 minus cos theta. And if I multiply it up on the other side, we get tan beta multiplied by PQ times by the root of 1 minus cos theta, which is what they wanted from us in the beginning. So the moral of the story with those questions, grade 12, is that initially that probably does look a bit confusing, okay? But work through it carefully, apply the sine, area, and cos rule as you would normally if you had numbers, and you actually generally that comes out relatively easily as you work through the questions. We're going to be doing more of these next week, guys, with also double and compound angles, so make sure you're with me next week, and we'll just help you some more with those.
Thank you so much. And on that note, here's an awesome quote I got from, well, it's not a quote, it's a comment from Sipiwe Kamokhelo. Sipiwe says, maths made me sweat, now I got it all. Swear I'm going to get my A with maths, working hard towards that. So thank you very much, and all the best, Piwe, and to all other mindsetters that are working so hard, sweating every day because of maths. Remember, maths is just easy. All you need to do is just to practice and practice. If someone can just get 100, you know what I love about his quotes is that positive attitude, because that, guys, that is such an important part of your approach to maths, is being positive about it. So true. You just need to always stay positive. But otherwise, mindsetters, exciting news is that only 76 days left before your final examination, which is starting on the 28th of October. So matriculants, get ready, and also for your prelims, we wish you nothing else but the best as mindset. Absolutely. Right. Absolutely, guys. And also, you know what, we're here to help the mindsetters. So if you have any questions that you think we can still help you with, go to mindset.co.za/learn/help desk. That's all we have for you. And thank you very much for taking your time and tuning in. We love you so much and wish you nothing else but the best, not the worst. Learn more, learn extra with us. And happy Women's Month to all the women out there, and the ladies. Peace from us.